An electromagnet that has a mass of almost 8 times 10 to the power of 6 kilograms. The mass of the electromagnet is 8 times 10 to the power of 6 kilograms. Was built at the CERN Particle Physics Research Facility. As a part of the detector in one of the world's largest particle accelerators, this magnet creates a fairly large magnetic field with the magnitude or the strength of the magnetic field is 0.5 Tesla. Consider a coil of wire that has 880 equal turns. So the number of turns in the wire is 880 turns. Suppose this loop is placed perpendicular to a magnetic field. So if this is the loop, the magnetic field is perpendicular to the loop. And we know that the normal line to the loop is also perpendicular to the loop. So the angle between the magnetic field and the normal is 0 because they are parallel to each other. So theta equals 0 degrees. To the magnetic field, which gradually decreased. So this was the initial value of the magnetic field, 0.5. The final value is 0 Tesla. In 12 seconds, delta T is equal to 12 seconds. If an electromotive force of 147 volts, so the induced electromotive force is 147 volts, what is the area of the coil? First, we start by finding the variation in the magnetic field, since we have an initial and a final value. Delta B is equal to B final minus B initial. So delta B is equal to 0 minus 0.5. We get the answer for delta B as negative 0.5 Tesla. Now, to solve, we will use this formula. The induced electromotive force is equal to minus N, the change or the variation in the magnetic flux over delta T. So EMF induced is equal to minus N. The magnetic flux we replace by its formula, BA cosine theta over delta T. We take the constants out and we keep the variable after the variation factor delta. EMF induced is equal to minus NA cosine theta delta B by delta T. We replace 147 equals minus the number of turns is 880. The area is the unknown. Cosine, the angle is 0. Delta B is negative 0.5 over delta T, which is given as 12 seconds.